Selection sort is an algorithm that conceptually is super simple. As with insertion sort and other algorithms before that, the array is divided into two sections. The left-hand side is already sorted. The right-hand side is not. The algorithm then traverses the unsorted section of the array to find the smallest element within there. It then moves this element to the very beginning of the unsorted section, or, well, that's essentially the same thing, the very end of the sorted section. That's where these two sections meet, right? After that, the algorithm then repeats these steps, these very simple steps, over and over until the entire array is sorted. And that's really it. There is really not a whole lot to explain here. In practice, the algorithm performs slightly worse than insertion sort, but for many, or like for small array sizes, both of these algorithms are actually better than some of the more advanced algorithms that we will cover in the future. Therefore, many inbuilt sorting routines that you might have used in the past without really thinking about them select these simpler algorithms for smaller array sizes and switch to the more sophisticated algorithms for larger array sizes of more than, say, 20 array elements. Anyway, let's head over to our numerical example. Okay, so I'm now in a new script called selection.py, and as always, we'll have our unsorted array 2, 5, 4, 1, and 3. Now, on the first pass, the algorithm says, well, nothing is sorted, so I'm going to look through the entire array to find the smallest element in there. And the algorithm correctly determines that this is 1. Therefore, 1 is swapped with 2. So 2 is now over here, and 1 is over there. On the second pass, the algorithm now searches everything starting at the second array element, because this is now the sorted section of the array. So from these numbers, 5, 4, 2, and 3, 2 is the smallest one. It's swapped with the second array element, because we are on the second pass. And yeah, therefore the array now reads 1, 2, 4, 5, and 3. Now comes the third pass. We are starting with the third element, and we're searching the rest of the array, 4, 5, and 3. We figure that 3 is the smallest array element. We swap it with the third element. The array now reads 1, 2, 3, 5, and then comes the 4. Now comes the fourth pass. We start over here at the fourth element. 4 is the smallest one. We swap it with the fourth element, and the array reads 1, 2, 3, 4, and 5. Notice that this would also work if we did not have all the numbers between 1, 2, 3, 4, and 5, but say we had, I don't know, 0, 8, 23, 48, and 107. This would still work. It would work in the exact same way. Now it's just that here it kind of feels like on the first pass, 1 is smallest. On the second pass, 2 is smallest. On the third pass, 3 is the smallest element, and so on. So this need not be the case if we have numbers that are not just spread out evenly over an interval of 1 to n, okay? But nonetheless, this is how selection sort works. Let's code this. As always, we'll define a new function, which I'm going to call selection sort. What a surprise. I'll define n as the length of the array. And now we'll just have a simple loop for I in range n-1. We are starting from here. We're going all the way over there, but we are not going to need a loop for that very last element. So we're only going until n-1. So we don't need 5 iterations of this loop to sort this array, because once we went through all the iterations and there's just 2 elements left, and we pick the smaller one of these and swap it with the other one, the last element will already be in its proper place, in its proper position. So this is why we don't have to have a loop going until n, but n-1 will be just fine. Okay, so what is it that we do? Well, we'll first try to find the index of the smallest element in the unsorted section of the array. That's a very long comment. But anyway, we'll now call or create a new variable called index smallest, and we'll set that to 1. And now we're going to traverse this unsorted part of the array. So for j in range, and now we're not going to start at 1 or 0. Here actually, I'm going to add this 0. You don't have to. If you don't add one statement within the range function, within the range method, it's automatically going to assume that this is the end of what you're traversing through. But here we're going to have to specify a start. So here we are starting at I, because if we are on the first loop here, we don't have to, well, we'll start at the beginning, but later on, we don't have to loop through everything all the time because, well, there's already stuff sorted that we don't have to go through. Okay, so here we'll now start at I, and this is going to go obviously until the end of the array, not n-1. So here we are now looking at everything. Now we'll now update the index, and well, when are we going to update our index of the smallest array element? Well, every time that we find another array element within that unsorted section of the array that is smaller than our previously assumed smallest array element of that section of the array. So if A in position J is less than A in position of what we previously thought of as the smallest array element, so A at index smallest, in that case, we are going to update our smallest index and set that equal to J. And then lastly, once we traversed all of the unsorted array elements, and once we found what that true smallest element is, we'll then make the swap. Okay, make the swap with the smallest element from the unsorted section of the array. So we're going to swap AI, and the AI, not AI, the artificial intelligence, the smallest array element. So here we'll now just have these two things in reverse order. You know how that works, AI. And I think that's it. I mean, we haven't introduced the yield statement yet, but let's see whether this works. So I'm going to define our array. I'm just going to copy paste. Well, no, we have to have the unsorted version of this. I'm going to go down here, and now we'll at the end we'll want to print our array, which is by then hopefully sorted. So let's type selection sort, run this, and yep, this is not working yet. So what is the problem here? Let me just go through this. For I in range 0 to n-1, that appears to be right. Index smallest is equal to, well, okay, here it says 1. This has to be I, and now it's working 1, 2, 3, 4, 5. So for some reason, I type 1 here. It has to be I, because within every loop here, we are starting at 0, but now we are starting at 1, at index 1. Now we're starting at index 2, which is the third element, and so on. Okay? So yeah, it's pretty simple. Well, how do we yield here? We could only yield on here when you're actually making the swap, but I think it would look kind of nice if we actually saw how the selection sort algorithm was looping through the unsorted section of the array. So I think somewhere up here it would be nice to yield because we're now seeing how J is being updated. Okay, so let's yield somewhere over here. So we're going to yield A. And then we'll yield J to highlight that we are now having a change in J. We'll also highlight I. That's just telling us where we are on the outer loop. And then I don't think we are going to use a third color here. Okay, so that's it, I think. I'm going to go into the animate function or script. I'm going to import from selection, import selection underscore sort. We're going to add this to our dictionary here. Selection sort colon selection underscore sort. Save this. I'm going to go over to the main, and we'll type selection, and let's run this. And there we go. Yeah, we can see that this is now working. It does not appear to be super fast, but this is also because, well, we're having a very big array here, but also because we're yielding at every step of this inner loop thing, okay? But anyway, I'm going to reduce this to 50, set the speed to maybe only 100, and okay, this is actually too fast, so I'm going to go with 20. And now we can see how this is traversing the inner array, passing it on to over here. And now that I'm looking at this, I think it would be kind of nice to not only highlight the position, but also the entire range, okay? The entire range of the sorted section of the array. And actually, as I'm looking at it right now, I think it'd be better to have this only run until one element before it, because, well, this is always too large and I only want this section maybe. Yeah, so let's do that. So I'm going to go back to the selection over here, and we're now going to highlight. We'll turn this into list range 0 until I. And remember, in Python, the range object running until I will mean that I is not included itself. So let's see whether that works. For some reason, yeah, well, on the first pass, nothing's to be seen there. But now we can see the sorted section and how it's getting over there. So maybe now, would it make any sense to now actually use the additional color? I don't really think it would. I mean, I think the idea now comes across. We are traversing this, and we are adding it over there. So let's go over here. We could maybe try just changing the order of the colors. So we'll now have this red section at the beginning, but other than that, that's not really going to do anything. What we could do though, we could use the third color to highlight the smallest index. So maybe that's actually going to look quite interesting. So yeah, I'm going to increase the speed here a little, and just to get going here, so we don't have to look at this super small section here. But now I'm going to decrease the speed. So notice how the bar is now moving a lot slower. And now, I don't know if this bar is actually any shorter. No, it was not, so it's not updating here. But now it's going to pick this bar, and I think this bar here is smaller, so it should now turn this into blue, which it does. Now this is the smallest index, and now it's going to take this and insert it over there. And I think, yeah, this is it. This is what we want. We have highlighted the sorted section of the array. We are really getting the message across of we are traversing the unsorted section, which is this yellow bar that's running through there, and this blue bar keeps track of which element we have to push over here eventually, okay? And we're updating this blue bar until we've found just the right blue bar that has to go over here, okay? So let's just, to sum up, or to bring this video to an end, let's increase this to 300, turn this to 100, and run this. Okay, this looks kind of bad because of how wide it is on my screen here, the animation. So let's just go with 100 bars, and now the bars go to the very top. And I think, yeah, this animation now looks pretty good. We've selected some decent colors that we can use here. And yeah, we have just implemented selection sort. As always, thank you very much for watching, and see you in the next video.